One, two. Good evening. This is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South on this 29th of November 2024. We say a very pleasant good evening to everybody that's tuned in to tonight on this last Friday of November, coming into a new month of December, and of course only just a few weeks before the good old Christmas. Anyway, pleasant good evening, and trust everybody is okay, and a very special thoughts go out to our stations, our folks up at Heathcote tonight. This weekend is the Starbecue weekend up at Heathcote, our dark sky site, Leon Mao dark sky site. The Christmas barbecue is considered the third of three big events that occur up at the site throughout the year, and I'm not sure the numbers that are likely to roll up there tomorrow, but you can probably expect anywhere between 200 to 300 folks that'll probably roll up. Just let me turn down the radio here, it's making a little bit of noise. Anyway, of course, having said that, as we're all aware, there's a fairly big storm front coming down this way. And I doubt very much whether there's going to be much observing of the sky happening tomorrow night. But knowing Heathcote, knowing that it is on the north side of the Great Dividing Range, more times than not, normally the sky clears by mid-evening towards midnight, despite the weather anywhere else. There is always a good possibility that there will be a parting of the clouds, and there will be a few hours worth of viewing, but unfortunately it's going to be a bit damp, and there could even be a little bit of flash flooding, which is known to occur up there. So my thoughts are with you guys if you're listening. I doubt whether you are listening to me and the bilge coming from here, but anyway, look, I was going to be prepared for a lot of things like I normally am on a Friday night, but I've come unstuck. My video program that I use to run the video side of the station here, which is called vMix, decided to give me hell about 30 minutes ago, saying that the trial version had expired. Now, I purchased a HT key, registration key for this a few years ago, and that really should be going perfectly well. Unfortunately, there was something I did just a few weeks ago because it hadn't been receiving updates or upgrades, and that only occurs for 12 months with this program. So I did acknowledge that, but I just noticed that the latest upgrade for vMix was well above what I had currently on the system. And I thought, what the hell, let's just upgrade to the latest version anyway. And that's kind of created a few issues in doing that. As a result, in getting everything up and running tonight, the supposed trial edition had expired. So I've been dealing with vMix, trying to get this my old version of vMix with my old registration key that I paid good dollars for back into service again, and I think I've done it just in the last 5 minutes. So That means that a lot of the stuff that I would normally import and get ready for tonight, I haven't been able to do, except for one thing. So it'll be a relatively short session tonight, I believe. I'm going to do things on the fly, and which is nothing unusual for a Friday night session. So that's about the way it looks at the moment. So I'm doing a lot of ad lib, and that's fine because that adds to the comedy of the situation. Anyway, you can see my producer's sleeping in the background there, Kiska, amongst the coaxial cable. She's keeping an eye on me there. So she says a very pleasant good evening to Lucy, who is Ian's producer. So I think we should get these two cats together, Ian. Well, this is a girl cat, by the way, and I think Lucy might be a girl cat too. But hey, you know, this is this generation, isn't it? All right. Having said all that, I can. Well, actually, I think I can. Yes, I can. I can go into the usual blurb for what's going on with the ASV. So, and we are also, well, I'll say that we are broadcasting on the prime frequency of 3541 kilohertz, and we're also broadcasting through the Melbourne television repeater, which is working tonight. I can see myself up there in full HD. So VK3RTV digital channel 1 is working tonight. I don't know whether there's any feed going out on the BATC feed, but nevertheless, it's there. And for all those that are watching the RF side of the repeater, so a very pleasant good evening to you guys. And also we're on Discord. So as I say, if you haven't got Discord as an alternative to YouTube, register on Discord. It's a little bit of a convoluted arrangement, but you can get there. Discord don't make it that easy to register. I don't know why there's a bit of a hassle with it, but it is sort of straightforward if you haven't registered before. If you're getting to Discord for the first time, everything you enter to register on Discord should be fairly straightforward, and there's no funding, no money involved. It's just registration. Then if you go to my qrz.com page, VK3EKH or VK3CSJ, you'll find a link which you can click on, and that should take you, well, it does in fact take you straight to the chat room and also the TV stream or the video stream associated with this broadcast. And like I say, it's a HD stream. And I'm paying for that stream, actually, for it to be HD, so we'll get there and view it. But it's less than a second delay compared to YouTube, which is some 20-second delay. So whatever I show you on the vision side of it is less than a second on Discord, and that's far better than having to listen to me carrying on 80 meters live and at the same time trying to catch up on YouTube. Nevertheless, I am running a YouTube stream anyway if it doesn't fall over. So far I've got red indications, which tells me that the links are working. So providing the RF doesn't get into the modem and causes a problem, you should be able to see visions coming from here, even though it'll be predominantly me. So that's it. I can show you a quick look at the sky up at Heathcote at the moment. For those watching visions, that's the live all sky camera up at Heathcote. So that's the view of the sky at Heathcote at this present time, which is pretty cloudy. You can just see the sunset afterglow from the sunset there at the west, and I'm not sure the reason why it's so bright there in the south, but it's probably a little bit of the city lights coming in from Heathcote, illuminating the horizon. But anyway, that's the sky at Heathcote as we speak. So, yeah. Anyway, getting back to just a little bit of information about the Society, if those that aren't aware. The ASV is a non-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members. In fact, it's around 1,800, I believe, now. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. I'd remove ordinary and just say councillors. The ASV has weekly activities at our two metropolitan locations, the Morley Community Village and the Melbourne Observatory. And we host monthly astro talks at the Herbarium near the Melbourne Observatory. The Society's library is also located at the Melbourne Observatory and is open during our astro talks. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. Our members conduct astronomy for the people gatherings, a bit like sidewalk astronomy, the Americans would call it, bringing telescopes and astronomy to Melbourne's parks and schools. Information about when these events occur can be found on the ASV calendar, which you can find on the website. So if you want to roll up to any of these events that occur, providing the weather is good, you can roll up and talk to any of the volunteers that are showcasing the telescopes, and you can talk about the society and how to join, and they'll show you and tell you everything you need to know. The ASV is currently involved in a number of major activities. They say here that they are involved in the restoration of the Great Melbourne Telescope, which was partially or pretty much destroyed by the fires that raged through Canberra many years ago and destroyed that poor old telescope. All that telescope all the parts that were remaining were brought back here to Melbourne, and there's a little location somewhere in Melbourne area where a group of volunteers, mostly ASV, but a group of volunteers have been engaged in the restoration of that telescope, and it is getting so close to being finally moved from its current location to its original home at the Melbourne Observatory. It's still a couple of years away, but it's getting there. And once the telescope has been re-established at its original house at the Melbourne Observatory, I am certain it will be a draw card for the public at open times. And it will be, as far as I know, it'll be a fully operational telescope, so you'd be able to look through it, and which will be a bit of a key thing because there's a lot of history associated with that telescope. Getting along with that, where was I? Yes, and also currently working on the installation of a series of remote controlled telescopes, which is pretty much complete too. I believe there's about 3, possibly 4 domes, but I think there's at least 3 domes that are up and running at the Dark Sky site, which are fully remote controllable now. And once you become a member of the ASV, you can register to be able to use these telescopes remotely for astrophotography reasons and stuff like that. Yes, thanks to the generous donation of one of its long-standing members, the Leon Mao Dark Sky site, located, as mentioned before, located north of Melbourne. It has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope and a 40-inch telescope there. There's also a 16-inch telescope, which is considered a disabilities telescope, because it's especially on a low support, and it allows people even in wheelchairs, for instance, to be able to access the telescope and look through the eyepiece. Oh yes, it doesn't mention this here on this particular thing I'm reading, but there is also a fully steerable 8.5 metre or 30-foot radio telescope, a Kennedy dish, exactly the same one that Doug MacArthur, the former or late Doug MacArthur, used up at his site on his property, the 30-foot dish, and this has been made to be fully steerable and currently has a hydrogen line receiver attached, a spectrometer, yes, so any involvement with that particular project can be done through the radio astronomy section. So a very pleasant good evening to any RAS members listening and watching tonight. There's also an annual yearbook which is published by the ASV, which looks a bit like this for those watching TV. It's quite a decent publication. As you can see, it's reasonably thickish, and it's very, very high quality publication. I don't know if I can easily do this on air like the way I'm doing it, but just trying to keep it in focus. Look at those colour images there and everything else. Yeah, it's very hard to do that. But anyway, it's kind of an almanac of sorts, and it gives you all sorts of information about about current events and events coming up throughout the 12-month period. Yeah. So anybody who joins the ASV will get this in their welcome pack. And yeah, what else was I saying? Oh yes, and the bi-monthly newsletter. I still refer to it as a newsletter, but it is now considered a magazine. But it's fairly thin on. It's more of a newsletter than a magazine. But anyway, it's the recent way this is being edited and published now. It's nice semi-gloss paper and beautiful colour images, and the articles that are presented by the members of the ASV are all worth reading. And I think there was something I was going to read from this too, if I remember correctly. Maybe I might do that later. I don't know. Anyway, we'll see. But that's the sort of thing you can get. And of course, a lot of other things. The ASV's logo, which I showed just a moment ago, this little fella, that's the ASV logo, which is nice and blurry and out of focus. And any second the camera will focus on that. Any second. Oh, it's very hard to do this live. Oh, there we go. Yep, there we go. Good old autofocus. Anyway, that's the logo, and there is a motto, a Latin motto associated with that, which I've been mentioning now for several Fridays now, which is I don't know how it's pronounced in Latin, but here it's got something like "Sic iter astra," and that's translated to "this way to the stars." The ASV is governed by a set of rules which should be read before applying for membership. The document may be downloaded by clicking here. Any person or organisation with an interest in astronomy may apply for membership of the society, which is all done from the homepage where it says membership. And I think that's still the case. It used to have a membership application just on the front page where it says join now. In fact, it says join now is where you can become a member via PayPal. Easy peasy. Right. Also, coming up on the 11th of December is our December monthly meeting, and the Astro Talk is going to be done the presentation will be done by a Dr. Kim Thalassides. I'm not sure how you pronounce that surname. It's got 26 letters in it.
Dr. Kim Thalassides. Anyway, and that'll be followed by Bill Stent, the telescope gent, as he's now known, and that's his surname. No, Bill Stent. Good old Bill. On what's up in the sky for December. And that'll be live in person at the Mulia Hall on the 11th of December, which I will try, if I remember, to televise live over the Melbourne TV repeater, like I did with the last session with Dr. Sarah, I can't remember her surname right now, but I televised that on the Monday that was on, and but usually the monthly meetings are held on the Wednesday, the second Wednesday of the month. So Colin Stanley Gum, the Australian astronomer who unveiled the Milky Way. Let me see if I can find out just a little bit more information on what's going on here with our monthly meeting, because there's a conflicting thing here I'm seeing. Let's see, where's the calendar? Looking for the calendar, there it is. And for December, I'll just go 1 month ahead. Astro Talk, here we are. Okay, so a bit more information. So the Astro Talk for Wednesday, December the 11th from 8 o'clock is by somebody by the name of Colin Stanley Gum. Oh, he's actually come in from... oh, I see. Okay, I'm just reading ahead of myself here. Okay, so Colin Stanley Gum, G-U-M, is every year we do a swap, presentation swap between the Astronomy South Australian Astronomy Group, ASSA. What is it? Astronomy South. The Astronomy Society of South Australia. That's it. Finally got it. ASSA. And for quite a few years now, there's been a kind of a swap thing going on where we send somebody to do a presentation with one of their meetings, and they send somebody to us to do a presentation. Well, this time we've got Colin Stanley Gum, and he's actually the first, doing the first presentation on Wednesday. And so it's what was the talk called again? Going back to the home page, it was given. They gave it a name. The Australian astronomer who unveiled the Milky Way. Now I'll go back to our thing that's going on, and it's. Hang on, go to December, Astro Talk, okay. So the largest single object in the night sky and 2 craters on the moon are named after Colin Stanley Gum. 1924 to 1960, a prominent Australian astronomer. Okay. Yet few people know the story of the young astronomer who spent his early years in the southern Flinders Ranges before graduating from the University of Adelaide, later with the first PhD in astronomy from Australian National University, the ANU. Despite personal challenges throughout his short life, Gum completed several impressive studies in both optical and radio astronomy, including a photographic survey of the Hydrogen Emission Nebula in the southern Milky Way, which revealed the spiral structure of our home galaxy. The presentation will span Gum's formative years in South Australia and his research and achievements as the University of Adelaide and Mount Stromlo Observatory. Now, I'm not sure who's presenting that. I had that kind of mixed up. I thought it was actually Colin Stanley Gum doing the presentation, but somebody, I don't know who it is, but somebody's doing a presentation on Colin Stanley Gum, who was, as I said, a prominent Australian astronomer in the years 1924 to 1960. Seems that he did quite a few interesting things. So I don't know who's doing that presentation, but that's happening on the 11th of December. So I'll give you guys enough notice of that for like next week, and also that'll be followed by a Dr. Kim Thalasidis presentation. Will be graced with a I see how it's written. Okay, so a Dr. Kim Thalasidis is doing the presentation on Stanley Gum. All right, and then following that will be Bill Stent's presentation on the sky for December. Well, that was all very confusing. My apologies. It's just the way it's written here. It's very confusing because at first it seems like somebody's doing so it seems like Colin Stanley Gum is doing the presentation, but it's not that at all. Oh, I'm sorry if that sounded confusing, but you'll get there. If you go to the ASV homepage and look under events and look for calendar under the events, you'll find that all what I've just written there under the calendar for December, and it's a free entry. Like I say, it'll be televised on YouTube, ASV's YouTube channel, and also on Facebook. So if you can't make it to the Mullior Hall in Melbourne, you can catch up with this wonderful presentation. I'm sure it's going to be most enlightening on YouTube and also on Facebook, and of course via the Melbourne television repeater. I'll do that. I'll broadcast it, do a live session of it. Struth. Okay, how about that? Half an hour now, all on this. How did I do that? Okay, so that is it. So any more information about the ASV, just go to www.asv.org.au. Having said that, I have not made myself a cup of coffee and I don't have a glass of water here, so I'm struggling. So what I may do to make things a little bit easier on me is I'll go straight to Tamitha Scove's latest weather report, which is downloaded into vMix. We did manage to do this. And let me see if I can bring up Tamitha Scove's cartoon caption. There she is, the luscious redhead. And get her all queued up. She's doing a presentation. It's a 12-minute, almost 13-minute presentation tonight. And she's all ready to go. And this was uploaded about 16 hours ago, so it covers the weekend, and I think covers up until Monday. So it's going to be fairly current what she has to deal with or talk about. So stand by, please, while I go and make a cup of coffee for myself. Have a listen to Tamitha and be enthralled. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast as it is. And here's Tamitha Scove, the space weather woman, Dr. Tamitha Scove, who's also a ham radio operator, W6SSW, something like that. I can't remember exactly. Anyway, stand by.
We have multiple solar storms on their way to Earth in time for the holidays, and a far-sighted blast leaves us in awe. Those stories and more in the news this week. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops. Space weather this week is picking up in a big way. As we take a look at our Earth-facing disk, it's all about solar storm launches, both on the Earth-facing disk and also on the sun's far side, and they seem to be triggering one another. Like this little prominence right here, as you watch it just gently erupt right off the disk like that, that seems to trigger the filament right here near region 3907. Watch it go whoosh. That actually looks like that could have been a solar storm that was headed partially towards Earth. But when we take a look at coronagraphs, you can see the signature. This isn't quite enough of a halo, so that means this structure is likely going to miss Earth to the south. Well, that's not going to bring us any holiday cheer, but that's not the only story. As we take a look at the east limb, you'll see region 3910, pow, right there. It's announcing its appearance in Earth view. This thing fires a near X-class flare, and it gives us a near R3 radio blackout over the Indian Ocean and Africa. It also launches a solar storm to the east of Earth, but we are going to be paying attention to this region as it continues rotating into Earth view, to be sure. Now, switching to the west limb of the sun, watch this gorgeous filament erupt. Look at this gorgeous ring of fire here. This is on the sun's far side, not Earth directed, but then it triggers region 3901 to fire. Pow! Right there, it fires what is a small solar flare with an R1 radio blackout. Not a big deal, but what is a big deal is the blast wave from this event. Look how much it encircles this part of the sun. This does mean that this solar storm that it launched is Earth directed. The sad thing is that when we go to coronagraphs to take a look at it, well, we can see that first little loop. Whoop, let me back up just a smidge. You can see that first loop come out. That's from that loop of fire, that beautiful ring of fire from the far side eruption that went to the west of Earth. But then as we advance just a little bit, ouch! Look at that. We missed most of the halo, and those missing frames make it very difficult to do prediction modeling. So we're going to have a bigger margin of error when we talk about the models that will be coming up in a moment. So that's not such great news. But outside of that, we are also watching region 3905 and 06. We've got a little burning filament in this region here that looks like it could be unstable. We're also keeping a close tab on this filament as well, and we do have a couple coronal holes, especially this one right here, which might give us a little bit of fast solar wind here at the end of the week. But we also are watching the east limb very closely, because there are a few, as you can see, a few wisps of fire coming off of there. So we do have some new regions that are going to be rotating into Earth view, and that's going to keep our solar flux up. That's going to keep our big radio blackout risk up, and it's going to give us more chances for solar storms here in the next week. And now, as we switch to our far-sighted sun, I'm back to showing stereo A imagery, because we had an amazing far side eruption that I want you to be able to see. Now, although stereo can't see everything on the sun's far side, you can see here's Earth, here's the sun, and here's stereo A looking at the sun just a little bit from the side. It did get a chance to see region 3889 after it left the Earth-facing disk. Now, back late on the 21st, region 3889 fires off a very large X-class flare. You can see it, boom, right there, and it launches a huge solar storm. In fact, it also launches a radiation storm. You can actually see some of the blizzard in the EUVI data here. But what made it so remarkable is that back here at Earth, we did get hit by that radiation storm, and it wasn't that it had huge fluxes. It wasn't a super intense radiation storm, but it did have some of the highest energies of a radiation storm that we've seen possibly since the Halloween events. This little yellow line that you see right here, this line is 0.5 giga electron volt. This is like cosmic ray energies. So this particular event is going to be one that's going to be studied for quite some time into the future. Sadly, we were not able to pass through this in situ to actually get an idea of how big the solar storm was. But we are watching region 3889 very closely as it rotates through the sun's far side, because we can see even here on the 23rd, it fires, boom, right there, yet another solar storm. So it's a very active region on the sun's far side. It is likely going to continue to be a producer as as it rotates back into Earth view. So taking a closer look at that region and taking a closer look at our simulated far-sighted sun using HMI and AIA data from about 2 weeks ago, we get an idea of what is in store for us. And matter of fact, as we take a look at our JSOC helioseismology far-sighted viewer, you can see the gold is the far side of the sun, and as we expected, those regions are, you can see region 3879 as well as 3883, 3886, and of course region 3889. These are still very well formed on the sun's far side. They are going to be rotating back into Earth view here over this next week. So aurora photographers, hey, there's going to be more solar storms very likely coming around in the next couple weeks. Amateur radio operators expect that solar flux to stay pretty high and actually expect the risk for big radio blackouts to rise as we move into next week, because these big flare players look like they're going to keep us quite busy. Now, returning to that Earth-directed solar storm, we switch to our solar storm prediction model, ENLIL. Now, this is NOAA's version of the model. Top panel's density, bottom panel's velocity. You're looking down at the sun from the North Pole with Earth being off to the right. And as we set this solar storm model in motion, you will see this solar storm coming out to the, basically to the south of Earth and to the east of Earth. And it looks like it's just going to be kind of a glancing blow at Earth, with impact being late on the 28th, kind of into the 29th. Now, there's also a solar storm that has been launched after that. It came from region 3905 and 06. You couldn't really see it on the disk very well, but we did get a little bit of it in coronagraphs. So as we switch to our solar storm prediction model from NASA, you're still looking down at the sun from the North Pole with Earth being off to the right. As I set this solar storm model in motion, we're actually showing two solar storms. First, the one that we expected from NOAA that is going to come and hit us on the 28th, but then also a smaller one that was launched kind of on its heels from region 3905 and 06. You could see that second storm right behind it. So this is the first one that hits us. NOAA's expecting a later hit than NASA. NASA's expecting us to be hit right about noon on the 28th. But then as I put it further in motion, and you can watch the second storm coming by, this one isn't necessarily going to hit Earth, but if we switch to our impact footprint, you can actually see it's going to be a reasonably close impact, but mainly to the east of Earth, and this will be sometime late on the 29th. So aurora photographers, get ready anytime from about midday on the 28th, clear through possibly the 30th. You might even get some decent aurora clear down to mid-latitudes. Switching to our moon, we are now passing through the third quarter phase on our way to a new moon, with the new moon being on the 2nd. So United Sky Watchers, if you want to catch some dim objects in the sky, like, I don't know, maybe some holiday aurora, well, now is your perfect chance. Switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating the hit from those solar storms that are on their way to Earth. At high latitudes, NOAA is expecting major storm conditions with up to about a 70% chance of possibly a severe storm. So aurora photographers, if you're at high latitudes, you definitely could get a show. Expect things to begin to calm down around the 30th, but then we are also expecting some fast solar winds. So early in the week, in early December, we could get yet more chances for aurora. Now, mid-latitudes, we're not expecting quite such a storm. On about the 29th, we're expecting to hit minor storm conditions, but we do have up to about a 20% chance of a major storm even at mid-latitudes. So aurora photographers, you definitely could get a show over this holiday weekend, and enjoy. Be sure to keep your batteries charged and stay on your toes. Now, switching to our solar flare and dayside radio blackout outlook over the coming week, we are still sitting well into the 200s for solar flux. This is because we have a lot of big flare players in Earth view right now. We are also hitting moderate noise on the dayside radio bands, and NOAA is giving us about a 65% chance of M-class flares at the R1, R2 level radio blackout over the next few days. That might actually rise to about 70 or even 75% chance as these new regions rotate into Earth view and we get a better look at them. We also have about a 20% chance of X-class flares at an R3 level radio blackout. So you amateur radio operators and emergency responders, expect the dayside radio bands to be a bit noisy, and expect the risk for radio blackouts to continue to climb over this coming week. Switching to our solar radiation storm and polar aviation outlook over the coming week, everything is in the green this week when it comes to radiation storms. We are sitting at the D1 normal range. This is at flight level 360 for you aviators. It is also the S0 quiet range for everyone else. Right now, NOAA's giving us about a 10% chance of a radiation storm at an S1 to S2 level, and that's because most of the big flare players are still sitting about on the east limb or on the eastern side of the sun. But that risk should rise as we go through the end of the week because some of these regions are going to be rotating to the sun's west limb. So expect us to get to maybe 15 or 20% chance for a radiation storm, which means you frequent flyers, make sure you take a look at the ICAO advisories because things could change quite quickly. So the space weather this week is picking up quite a bit. We have those Earth-directed solar storms that should be hitting us right around the holidays. If you are an aurora photographer at high latitudes, you could definitely get a show starting about midday on the 28th and possibly having it last until about the 30th before things begin to calm down. Aurora photographers at mid-latitudes, well, your window of opportunity is a little bit shorter, but you still should be able to get some decent aurora over the holiday. So keep your batteries charged and your camera at the ready. And now amateur radio operators and emergency responders, well, the news isn't so good for you. We do have the noise creeping up on those dayside radio bands, and that's because we have those new regions rotating into Earth view from the sun's far side. They are big flare producers, so that means the risk for big radio blackouts is going to creep up over this week and next. So you're going to have to just hunker down and try to get through it. And now you GPS users, well, we do have those solar storms that are going to cause some issues for you on the Earth's night side with aurora, and we do have the risk for radio blackouts also creeping up. So if you're anywhere near aurora or you're near the dawn dust terminators, definitely stay vigilant because your GPS reception might be a little bit off, but outside of that, you should be pretty much in the clear. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Okay. Thank you, Tamitha. Just make sure my audio levels are there. 1, 2, 3, 4, 5. Yep. All right. It sounds like a lot of things happening this weekend in more ways than one. Thank you, Tamitha. Her call sign, I did have that. Looks like I removed that. Did have a caption card for that. It doesn't look like I've got it there. Must have removed it. Doesn't matter. All right, you're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria with the regular Friday night broadcast. Okay, well, that's 10 minutes or so. Gave me an opportunity to make a cup of coffee and a glass of water. And also to bring up a couple of interesting images that have come through this week. Let me see if I can go to the article. The Sombrero Galaxy doffs its cap to the power of the JWST. Doffs, D-O-F-F-S. Is that an Americanism? Anyway, the Sombrero Galaxy doffs its cap to the power of the James Webb Space Telescope. And let me see if I can, what I'll do is I'll bring up the Hubble image of this amazing place first. Where is it? There. Okay, this is what I'm talking about, guys. Or about coming up to anyway. Excuse me. The James Webb Space Telescope shows off its infrared capabilities once again in a new image of a well-known Sombrero Galaxy, Sombrero, otherwise known as Messier Object 104, by resolving the thickly textured dust clouds in the outer disk and toning down the brilliant central star glow. The James Webb Space Telescope shows a whole new side of the famous galaxy.
In visible light, the system looks much like its namesake, with a broad, flat disk of brim for a brim and brilliant central core, which is what you're seeing on the screen now, shining with old stars. But the James Webb Space Telescope's the James Webb Space Telescope eyes the skies in infrared light. Oh God, the wording. Anyway, eyes the skies in infrared light, where many objects take on surprising appearances that don't always align with the visible light counterparts in the image that you see here. This is what the James Webb Space Telescope is now seeing. This is why it's up there doing its magnificent stuff. So what you're seeing is in normal optical wavelengths, using the Hubble, and this is what the James Webb Space Telescope sees using its infrared capabilities. So we cut back to the Hubble, and that's the Webb. So it's pretty outstanding. Okay. This means that for James Webb Space Telescope's view of M104, the bright core is diminished to a small spark. Without that overwhelming glow, the overall galaxy appears empty, replaced by now visible smooth inner disk. But this is misleading. M104 is far from empty. In fact, it contains more stars than the Milky Way, though it is roughly the same size. JWST's predecessor, the Spitzer Space Telescope, also obtained an infrared view of the Sun Barrow, painting it more like a bullseye than a hat. And that's what the Spitzer. This is what the Spitzer. Oh, hang on. I did download the image, but I haven't brought it across. Let me just find it for a sec. I know it's here somewhere. Yes, it is here somewhere. I don't know. I'm pretty sure I downloaded it, but I'm just going to have to do that again. So bear with me while I close that first of all and go back to the article and just collect that image. There it is. Change the web to JPEG. It annoys me how some of these URL files have web attached to it. You can delete the web and just type in JPEG to store it as an image. And let me see, I'll put that into my Astronomy Friday night file. Yes, it's telling me it's already there. So it is there somewhere. So I shall try and transfer it across to vMix again. Image, and it should be just there in front of me. There it is. It worked this time. So this is what the Spitzer telescope is seeing in infrared as opposed to James Webb. A ring of red. As it says here, James Webb Space Telescope's predecessor, the Spitzer Space Telescope, also obtained an infrared view of the Sun Barrow, painting it more like a bullseye than a hat. But Spitzer lacked what JWST's stunning resolving power. JWST's advantage is obvious in comparison. So in the JWST's image, and I'll just go back to that. Okay. The outer disk shows detailed texture like ruffled clouds, which represents clumps of dust. And in many galaxies, such sites are often where stars are forming. But star formation has slowed to a crawl in M104. In fact, M104 is known more for its older star groups, globular clusters. it has far more than its fair share, some 10 times more than the Milky Way, despite being only modestly bigger. Globular clusters are stars that are bound together gravitationally, resembling a sort of miniature irregular galaxy. Many of the stars in a globular are siblings, born from the same molecular cloud. But most globulars also contain interlopers, or multiple generations of stars. Astronomers are still teasing out the secrets of these clusters and how they continue, or how they can contribute to galaxy formation and evolution. The Sombrero Galaxy is a magnitude 8 galaxy, only about 30 million light years away, making it a popular and easy target for backyard observers, as well as NASA flagships. But despite the popularity, the sharp infrared gaze of the James Webb Space Telescope can still reveal new details in this old favourite. So there it is, the Sombrero Galaxy, or M104. And this is, of course, how we've known it usually looks. So it's pretty amazing, isn't it? It really is quite a stunning thing. All right, you're tuned to ASV Radio, VK3 Echo Kilo Hotel. Okay, this is where things get a bit mixed up a bit. Let me see if I can find another article for tonight. This is why I usually have time to get this all sorted out, so my apologies for the way things have occurred tonight. 3 days ago, a strange signal beamed at Earth from a dead star can finally be explained. That sounds interesting. See, this is what I do. I look for interesting things to read. That sounds interesting. Maybe I've already read this out. No, hang on. The article was published... No, maybe I have. It's 26th of November. That was Tuesday. So no, I haven't read this out. This is fairly current. Okay. Now, there is a few images associated with this article. So what I might do, that's probably not really important. I don't know if that graph is important. There is a video here. It's a pulsar sound, actually. They've got a crab pulsar sound here. Oh, let's see, here we go. All right, this is the article, courtesy of sciencealert.com. A strange signal beamed at Earth from a dead star can finally be explained. From within a glowing web expanded outward from an epic explosion, a dead star is flashing pulses of radio light at Earth. This is the well-known Crab Nebula, or Crab Pulsar, and within its radio pulses is a strange signal that has puzzled astronomers for years. It's called the zebra pattern. Actually, this is all new. I haven't heard of this before. It looks like a strange spacing of wavelength bands when graphed, resembling a spiky zigzag stripes of a zebra. Nothing else in space has an emission quite like it, and astronomers have sought an explanation since the pattern has first observed nearly 2 decades ago. Now, a theoretical astrophysicist thinks he may have solved the mystery. It says Mikhail Medvedev of the University of Kansas, an interference pattern generated by the diffraction of light by different plasma densities inside the pulsar's magnetosphere. If you have a screen and an electromagnetic wave passes by, the wave doesn't propagate straight through. In geometric in geometrical optics, shadows cast by obstacles would extend indefinitely. If you're in the shadow, there's no light. Outside of it, you see light. But wave optics introduces a different behavior. Waves bend around obstacles and interfere with each other, creating a sequence of bright and dim fringes due to the constructive and destructive interference. The Crab pulsar is the hectic remnant of a supernova some 6,200 light-years away that bloomed in Earth's sky in the year 1054 CE. It was the spectacular death of a massive star ejecting its outer material in a violent sneeze. The core at the star's center, no longer supported by the outward pressure of fusion, collapsed under gravity to form a neutron star. These ultra-dense objects are tiny, the heaviest packing up to 2.3 times the mass of the Sun into a sphere just 20 kilometers across. A pulsar is a type of neutron star that blasts jets of radio waves from its poles. As the star rotates at incredible speeds, these jets are like lighthouse beams that sweep past Earth in such a way that the star appears to pulse. The Crab pulsar has a rotational period of about 33 milliseconds, which means it pulses about 30 times a second. And they do have a sound file here. I don't know whether I can play this and whether you can pick this up. I don't know. I don't know whether this will work. Sure. Oops. If that went across on TV, probably didn't. But I know you guys on 80 meters heard it because I heard it. So, but that is a pulsar. That is the sound of the Crab Nebula pulsar. It's amazing, isn't it, to hear that? Oops. So, I think I'm back on TV. Let me just check my audios there. Yep, I am. So astronomers have been studying this pulsar since its discovery in the 1960s in the middle of the bubble of expanding debris, making it the first star to be confidently linked to a supernova event. It still has its mysteries more than half a century on. The mysterious zebra pattern wasn't discovered until 2007, and boy was it a conundrum. It's very bright across practically all wave bands, says the astronomer here. He says this is the only object we know of that produces the zebra pattern, and it only appears in single emission component from the Crab Nebula. The main pulse is a broadband pulse, typically of most pulsars, with other broadband components common to neutron stars. However, the high-frequency interpulse is unique, ranging between 5 and 30 gigahertz, frequencies similar to those in a microwave oven. Yeah, okay. Since we've been observing the pulsar so intently for so long, there's a wealth of observation data available. The astronomers have taken this data and, working from the assumption that the zebra pattern represents a diffraction fringe, developed a model based on wave optics to calculate the pulse's plasma density. The model accurately replicated the observations, providing a deft explanation of the pulse's strange behavior. As the radio waves beam out from the pulsar, the astronomers found interactions between the plasma and magnetic field produced a diffraction interference pattern that looks like a zigzag zebra stripes. A typical diffraction pattern would produce evenly spaced fringes if we just had a neutron star as a shield. But here, the neutron star's magnetic field generates charged particles constituting a dense plasma, which varies with distance from the star. As a radio wave propagates through the plasma, it passes through diluted areas, but it is reflected by dense plasma. This reflection varies by frequency. Low frequencies reflect a large radii, casting a bigger shadow, while higher frequencies create smaller shadows, resulting in different fringe spacing. The model could represent a new tool for measuring the plasma density inside magnetospheres of pulsars and other extreme environments where diffraction patterns can be found. Although there's nothing in the sky quite like the Crab pulsar, there are other places and ways of what the model can be applied. The Crab pulsar is somewhat unique. It's relatively young by astronomical standards, only about 1,000 years old, and highly energetic. But it's not alone. We know of thousands or hundreds of pulsars, it says here, with over a dozen that are also young. Known binary pulsars, which were used to test Einstein's general relativity theory, can also be explored with the proposed method. This research can indeed broaden our understanding and observation techniques for pulsars, particularly young, energetic ones. This research has been published in Physical Review Letters. Well, yes, good old Crab Nebula. That's certainly one pulsar. I remember saying that our 30-foot dish up at Heathcote, the Radio Astronomy Group dish, should be capable of receiving some of the strongest pulsars, the Vela pulsar, and certainly the Crab pulsar is one that the dish should target to see what we can receive of it. The signals might not be strong enough to be able to resolve the pulsing in terms of audio, but certainly using special software, you'd be able to accumulate the data and be able to resolve a waveform, and I think that's the best that we can possibly do. I remember saying a long time ago it'd be a real an interesting thing to be able to have the dish focused on the Vela pulsar, or let's say the Crab Nebula Crab pulsar, and during the Starbecue, which is like tomorrow, have people come in and say, "Oh, where's the dish pointing right now?" And we say, "Oh, we're currently tracking the Crab Nebula pulsar, or the Crab pulsar, or a pulsar that we can actually hear in the speaker. And by the way, turn the volume up. This is what it sounds like." I've always imagined that being one of the scenarios that we demonstrate up there with the telescope, but it may not be as easy as that, actually, without having the capture area of a bigger dish antenna such as the Parkes radio telescope. So we might be just on the edge of being able to do that on a 30-foot dish. But there are techniques. We do have techniques these days, software techniques that might be able to resolve the signal enough to produce a similar sound. Anyway, I'll leave that to the guys that are up there now doing all that, so good on them. Anyway, you're tuned to ASV Radio VK3EKH, where I've managed to waffle on enough for an hour. I'll now go on to just a very quick rundown of spaceweather.com. The solar wind is currently at 396.5 kilometres a second at a density of 3.94 protons per cubic centimetre. The disk of the sun currently looks like this, if we were able to look at the sun right now through appropriate equipment.
And so the current sunspot number is 149. The radio sun, measured at a wavelength of 10.7 centimetres, is 225 solar flux units. That's pretty high. 225 solar flux units. The aurora over Antarctica as we speak looks a bit like this, and it's not much to write home about. Despite the potential flare activity, there's only very less than moderate activity over the aurora over South Pole at the moment. So not much would be visible in the skies at this point, if you could see anything at all. Spaceweather.com is reporting a weak CME impact. They say here that a CME hit Earth's magnetic field on November 29 at 02:45 hours UTC, but the impact was so weak that it did not spark a geomagnetic storm. The G2 storm watch previously issued for November 29 was cancelled. And there's a little bit of a report on aurora activity and some technical information. There's no significant coronal holes facing Earth at the moment from the Sun. And the KP index, the planetary K index, KP is currently equal to 1.67, which is considered quiet. The 24-hour max KP is equal to 2.33, which is also considered as quiet. I think that's about it from spaceweather.com. As of November 29, there were 2,349 potentially hazardous asteroids, which has been the same figure now for the last couple of months. That hasn't changed much at all, really. So that is the current spaceweather.com. And I think that together with Tanya's report, I think you will be all up with the latest in solar weather. So, I think that's about it. All right, 11:06. Hopefully my VMix will behave itself for next week. Being December, I plan to finish up, I think, I go on a 4-week break over Christmas, and I think my last broadcast I will do for the year will be, I'll make it the 20th, Friday the 20th. That's when my holidays basically start. But I'll make the last broadcast for 2024 on the 20th, and I'll come back probably on the 10th of January. So there'll be a bit of a break. Deserved break. Hopefully I can get this station that I'm in here a bit more into order. But anyway, I'll let you know all that on the last broadcast and all that sort of stuff, so you're up to date. Yeah, I think that's how it will go. Okay, enough of that waffle. Let's see. I'm still on YouTube, believe it or not, and I believe I'm still on Discord. It hasn't fallen over. So what I shall do now is go across to 80 meters, and I think my audio feed from the speaker is ready to go. If I turn the volume up there, I should be able to feed back a little bit of 80 meters over the digital side of the station here, so people watching Discord, YouTube and the TV up there can hear what's coming over 80 meters. So all right, just make sure my pen is working. If there are any stations wishing to check in tonight, please come on now. This is VK3EKH listening.
VK3GL. VK3STX. VK3 Delta X-ray.
Okay, that last station with the X-ray, what was it again? Last station.